Today we're going to take a look at Buys-Ballots Law. Now, Buys-Ballots Law is a very simple principle that can show us where high and low pressure systems are situated based solely on direction of cloud movement. Let's take a look.
When we talked about where wind came from back in Chapter 6, we discovered that there were four main forces that drive wind. The first force is the pressure gradient force. Remember, this is the force that kicks everything off. It is caused by the difference in pressure from high to low, and is going to drive the wind in that direction. The second force is the Coriolis force, which has to do with the rotation of the Earth, and we'll take that initial wind and we'll turn it until it is parallel to the isobars. The third force we don't need to hit on very much right here. It is centripetal force. You can look back at Chapter 6 for more on that. The fourth force is friction. Basically what friction will do is slow down the wind and it will weaken the Coriolis force. As such, the balance of wind will actually be about 30 degrees from being parallel to the isobars. So the important point is the winds aloft, because of the Coriolis force, the winds will be parallel to the isobars, and friction at the surface, because of friction, it will be nearly parallel, about 30 degrees off. Notice that if you follow the direction of the wind, that the high is going to be on the right side of that, the low on the left. This is the crux of the Buys-Ballots Law. So let's say that you have a cloud above you, and you watch the motion of this cloud, and this cloud is moving from the southwest to the northeast. Well, from what we just saw, that wind aloft is moving parallel to isobars. So the only way for that to happen is for the high pressure to be on the right and the low to your left. So the general rule of thumb, look at the clouds, turn your back to where they're coming from, face where they're going. The low will be on your left, the high on your right. If you ever forget that, just think low, left, both begin with L. Now, what if there are no clouds? Well, we can determine the high and low pressures from the wind. Remember, here at the surface, we still have wind. So let's say we've got a biker here who's feeling the wind going from south to north, turns his back to the wind. He's going to turn to the right 30 degrees. And then, after he turns right 30 degrees, high is on the right, low is on the left, same as before.
Here I am at Daytona State College behind the science building on the Daytona Beach campus. I'm looking towards the north here, or you are looking towards the north rather, and I'm looking this direction to the south. So the east would be this direction and west there. Now let's take a look and see where our clouds are moving, and from that we'll be able to tell where the high and low pressure systems. So what we see from that time-lapse video is that your clouds are moving west to east. So according to Buys-Ballots Law, if I turn my back to where the clouds are coming from and I face the direction they're going, I am now facing east. Then according to Buys-Ballots Law, the high pressure is on my right and the low pressure is to my left, which means that the high is going to be to the south and the low to the left. Let's take a look at the map and see if we're right.
Now here we are on the Weather Tools page for our course. We're going to scroll down past the satellite images as well as the upper level charts and come down to the surface analysis for Florida. Now outside, when we did the Buys-Ballots Law, we predicted that the high pressure would be to the south and the low pressure to the north, and we predicted this because the winds and the clouds were moving to the east. So let's take a look here. We've got our station here in Daytona Beach with the pressure on the top right, 163. Remember from Lab 2 that this is coded. This means 1016.3 millibars. So now what we need to do is compare the stations around us here. We predicted that to the south, the pressures would be higher. Let's take a look. Down here we have 1017.2, 1016.6. There's a 1017.5, 1017.5, 1016.7, so on. So yes, to the south, pressures are indeed higher, and probably more towards the southeast particularly. Now let's look to the north. So we're at 1016.3. If we look to the north, we've got 1016.2, 1016.1, 1015.4 is what that looks like there, 1015.5, and so on. So yes, to the north, the pressures are indeed lower. In fact, here we have our isobar that says 1016, which is lower than our pressure here of 1016.3. So in general, I would say that the line from high to low would be high as in the southeast, low would be to the northwest. We're pretty close. Ideally, when we do the Buys-Ballots Law, you'd want to look at the clouds directly above you. That would give you the best perspective, but for the video, it looks like it was to the east, close enough for us. So southeast toward northwest, our Buys-Ballots Law checks out.
But what if there aren't any clouds? How can you tell where the high and low pressure systems are without any clouds? Well, where there aren't clouds, there is wind. So right now, I've got wind coming from the southwest going towards the northeast. So I'm going to turn my back to the wind, southwest, and it's looking to the northeast. Now remember that wind is driven by four forces. The fourth force is friction, which actually turns it to the left by about 30 degrees. So I'm going to correct for that by turning back to the right about 30 degrees. Notice I'm facing east again. Well, where are my pressures then? High is on the right, low is on the left, which means the highest to the south, the lowest to the left. It still fits.